Okay. This is probably one of the last interviews I will have because I have a mentoring session in a few minutes. Welcome, my next guest. What is your name and what brings you to JCON?
I'm Merlin Bögershausen. I'm a software engineer at Modern, and I'm at JCON to also give a mentoring session about how to advocate for change, and gave a session about spoil for choice and overcoming the spoil for choice in terms of library usage, in terms of API usage, because we see the problem of diverging API adoption, diverging dependency versions, dependency styles, like you have Apache Commons Logger, Log4j, SLF4j, Logdash, and they're all good choices and or was good choices in a point of time. Now they're probably no longer. You have to migrate to one or the other. And with Open Rewrite, we can do this very easily to achieve this consolidation in the tech stack and to move it forward to some liquided style of text to no longer be kept inside a prison.
We already had Modern and Open Rewrite in the podcast before, so it helps you evolve your code. So it has some rules and improves your code. So I know it can, for instance, bring you from Spring 2 to Spring 3. But you say you can also use it to combine several libraries, or say, yeah, you have different logins. This is maybe a better approach.
Open Rewrite can be used to streamline your tech stack, to achieve some consolidation of the tech stack in terms of if you have a big organization. From time to time, this was in the past it was a good choice to go with Apache Commons logging. Then it was a good choice to go with SLF4j and with Log4j, and all of them were valid choices at their time. Some of the projects are just maintained on a minimal level, and some of them have different version in use. So we have a wide variety of libraries used for logging at all inside one organization, but an organization should stay on a common code style of coding that includes library and API usage. And with Open Rewrite, we can migrate from one library to another library, or in terms of SLF4j, from SLF4j to SLF4j, to streamline the versions, to streamline the API usage, and to achieve a more standardized use of the API.
I've seen this before in older projects, legacy projects, that suddenly seem to have 3 different XML libraries. So this is a bit the same idea. If you only need one, that's a better approach.
Yes. And what we also see in big organizations is that even if they have central management of dependencies in terms of versions, and as a big parent or something like this, or a bill of material, there are still different versions, for example, JCON in use. But if you're connecting two services with a completely different version of JCON in between, that could be a problem in the future, or could be right now. And if you're using a recipe to migrate all of them to the same version, to the most recent, without CVEs, without problems of end-of-life cycles and something like this, so then you have, again, a more standardized way. And when you have this standardized way and the standardized use of APIs, you can move even faster towards different cloud provider, towards a different implementation and different application service to overcome these vendor lock-ins, to achieve more digital sovereignty, and get rid of a special provider.
Yeah, that's the great thing about Java. You have this great community creating libraries, but CVs, you mentioned them briefly. So an older version can also have security issues. Is that something you can alert, detect?
That's definitely something we can alert. So with Open Rewrite, there is a recipe. It's called find and fix vulnerability dependency with vulnerabilities, and it is using the GitHub Code Advisor Security Advisor database, and to move migrations, to detect migrations with CVEs and migrate to a fixing version. And this recipe can be applied from time to time. And whenever this recipe finds something, there could be an alert, or there could be an automatic fix for this. With the feature called data table, every recipe can be used to collect data auto-transform code. The collecting data feature can be used to build dashboards on top of that. So we do this with our modern SaaS, with the software as a service solution. There's some, you can develop their dashboards and characterize your current data you have available for CVEs, for unpatched versions, for out end of life versions approaching. So all of them is
Patching it, going to a newer version with the CVE fix could also need some changes in the code. Are there recipes for that for each library, or can some manual work still be needed?
That's something, usually the CVE fixes are fixed with the bug fix. For very old versions that have a CVE, there might be the suggestion to, we don't want to support this any longer. It's the end of life problem. You should migrate to a newer version. At this point, the final fix vulnerability recipe can be configured to just update bug fix releases, to upgrade minor or even bigger releases. But the code fixes need to be written as special recipe again. So there's no magic in behind detecting breaking code changes and writing some kind of recipe for it. It's still a human to have to write this. But for the most common end of life libraries that are in our ecosystem, there are already migration recipes available. So it is safe to say, okay, I have a very old library. Let's migrate JCON from 2.1 something to 2.18 or something, and then probably the CVE is fixed anyway, or then supply the fixed version.
I saw there was also the announcement that you will cooperate with Azul to find dead codes. How does that work?
Azul has this very neat feature that they can analyze your code in production in runtime and identify methods or code passages that are never used in the last weeks, months, years, or something like this. And with this data, you can go to your code and remove that code. You can do that by hand, or you can use the modern tooling. We have a recipe for this. This is working together with the Azure Cloud solution, which is pulling the data, which method, which code passage is no longer in use, and then removes this code, opens a PR, so the team don't have to do it manually. They just have to accept. That's the same for, this is combined with removing unused imports, removing unused dependencies, because if the branch is deleted, probably a dependency is no longer needed. All of this comes together with this recipe, with this data coming from Azul, and is being serialized, made reality with Open Rewrite Modern.
So removing that code helps you to have less work as a developer, less code to maintain, because some people don't realize that unit tests need to be kept in sync with code, which is probably sometimes never used.
Yes, because unused code within one project, we can easily determine unused code by following the code path. The problem is if you have a public method, then it is a used call, and everything what is following this public method is considered used call. With the data from Azul, we can determine, no, it isn't used in the last 5 years or something. It's safe to delete, and then we see, okay, it's also safe to delete to this private classes here because it's no longer used. It's also okay to delete these unused test cases here. It's also okay to remove the dependencies at whole. And so they're just one method that is flagged as this method is no longer used can end up in a full module being removed because it's no longer used. And that's the beauty. Deleting code is always a good thing.
Deleting code and clean code and readable code, up-to-date code, so all things that you can help with Moderne to achieve that.
Yes.
Okay, thank you for your time. Thank you for being here. Thank you for the talk, and have fun at JCON.
Thanks for having me. Thank you. Bye.